ready to start another lesson. We are still in the planning performance domain, and now we will be talking about estimating. How do we estimate? And we have to look first at the principles of estimating. What are those principles? Estimating is very important because the good estimate provides us with important elements like the time to complete an activity and the cost to complete the activity. So estimating is very important because it will help us to create financial parameters, financial estimations, and time estimations. Time information will help us plan and schedule activities using networking techniques like the activity on the arrow or the activity on the node. And typically today we are using more the activity on the node, but it's possible that you still find some old schedules using activity on the arrow methods like the arrow diagram method and the PERT method. Time estimates can be given in absolute terms or relative terms. We can find a time for an activity to complete. We can say it will be so many days or so many hours. On the other hand, we can also have a relative estimation like the system used in Agile, in Scrum, the Fibonacci poker, where we are comparing the effort of the different activities with each other, and we're not really considering an absolute time duration. We're looking at a number of points that we need to create some activity or to complete some deliverables. When we look at the cost estimates will be very important when we want to create the project budget. When we look at the range of estimating, we are not 100% sure about the exact number or the exact time and cost an activity will take to be completed. We only know that once the activity has been completed. Now, when we look at estimates, we look at different estimation ranges. We can talk about a rough order of magnitude, and of course we have different parameters from previous projects. It depends also on the amount of information that we have on the activity that we want to estimate. When we start with the planning, we typically give a rough order of magnitude, which can have a range of minus 25% up to plus 75%. Companies can define these. Companies who are serious about project management, they will define what these parameters are. For example, a rough order of magnitude may be between minus 50 to plus 100%. Now, when we continue with the planning, when we have more information about the project, the range will become narrower. For example, at the end of the plan, we can or we should have an estimation that the cost or the time will vary between minus 5 to plus 10%. These are typical ranges that are used in project management. For example, a cost which exceeds, for example, 10% of the estimate, that's not something that is really accepted. You have to have an explanation why this happened. But typically, 10% is an acceptable range. It's an acceptable difference. On the other hand, when you see that you're too much below the estimate, it's also not good. So typically, minus 5 to plus 10%. If you're outside of that range during execution, you will have to explain why you are there. Let's now have a look at estimating accuracy and precision. Accuracy refers to the correctness of an estimate and how close you are to the real value. Precision is different from accuracy. It's about the degree of the exactness or the spread around an average value. When we look at the game of darts, we can have a high or low accuracy with a high or low precision. Are the darts close to the center or the goal that you wanted to reach? And how are those darts spread around it? These are different parameters. We also find this when we look at statistics, the spread around an average value. How close are we to the average value? These are all parameters that we have to consider. When we look at estimating and confidence, well, it's not easy to estimate properly. When you start as a project manager, you may have to depend on information from the systems, from the PMO, from more experienced people. When you have more and more experience, your estimations will be a lot better and your experience and your confidence is growing. When you compare similar projects, it can be quite easy to make the estimates, but when you don't have the experience or you didn't work on a similar project, there may be some additional issues related to estimation and the confidence you have. Organizations have lessons learned and they will support you by sharing experience and knowledge obtained from old projects. Another element we can in fact consider is the difference between a deterministic and a probabilistic estimation. Deterministic estimation is also referred to as point estimation and provides just one number or amount, a specific time or a cost. Probabilistic estimating includes a range of possible values, typically given as an average and a standard deviation. Both can be obtained by simulations like Monte Carlo or weighted average using multiple likely outcomes, for example, an optimistic, pessimistic, or probable estimate. When we look at probabilistic estimating, we also may discover or know the probability distribution of the activity, and we can then use these parameters to include them in special design software. When we look at the characteristics of an estimate, estimates can be obtained using computer models, and we typically can use Monte Carlo simulations, and typically they show the following characteristics. A point estimate with a range of 1 week, for example, plus 2 minus 1 days. Assigned confidence levels. We can have a probability distribution with a dispersion of the data around a given average. And in some cases, we can assume specific distributions, like the beta or triangular distributions, and find an average and a standard deviation based on a simplified formula. We will talk about this when we look into the PERT and the 3-point estimations. We also consider absolute and relative estimating. Absolute estimations are specific and they are expressed by a number. For example, the activity will take 3 8-hour working days to complete. Relative estimations are expressed in comparison to other estimates. They only have a meaning within a specific context. For example, when we have the Fibonacci estimating and Fibonacci poker in Scrum, we look at relative estimations of effort between different activities. We have the PERT estimations, so when we looked at the 1950s, there was a probabilistic estimation method called PERT developed, which was based on a beta distribution. Now, this was a first attempt to bring probabilities or probabilistic elements into estimations. The system worked quite well and it's still used today. We still can calculate the PERT estimate of a duration or a cost. The PERT estimation is based on a simplified formula using an optimistic, a probable, the mode, or we call it N, and a pessimistic estimate B. And it was derived from the beta distribution. Beta distribution is a distribution which can have different forms depending on different form factors, alpha and beta, and a start, a minimum, and a maximum value. Based on this distribution, you can develop a simplified formula, and the simplified formula contains 2 parameters. We have an expected duration or an expected cost and a standard deviation. In case of the beta distribution, the expected duration is A plus 4m plus B divided by 6. This is a weighted average where we give 4 times the weight to n compared to A and B. And the standard deviation is given by B minus A divided by 6. This simplified formula provides us a probabilistic estimate of the duration of a project, for example, or the cost of a project, and we can calculate the probability that a project, for example, would be completed in less than a certain time or more than a specific time, or what's the probability that it will finish between a minimum and a maximum time. Based on these two elements and based on the normal distribution, these calculations can be done very quickly, and it was used in certain programs like Crystal Ball. Crystal Ball was using this method, and a lot of software programs contain these parameters into their programming. Another estimation is the 3-point estimation. In this case, we do this distribution, or we use the triangular distribution in case we are not sure about the form of the probability distribution. We don't really know the distribution, and we have a different calculation method. So we replace the beta distribution by a triangular distribution, and we also calculate the different parameters based on the three estimates, the optimistic, the pessimistic, and the probable estimate, which gives us simplified formulas. Now the expected duration is the average of the optimistic, the mode, and the pessimistic duration, while the standard deviation is b minus a, the range, divided by 5 and not by 6. We will see when we do the calculations that the values here are typically higher than the values obtained by the PERT estimation. So there is more, let's say, safety built in this system. We also have flow-based estimations. A flow-based estimation is based on the cycle time and throughput, like we do in processes. The cycle time is the time for one unit to go through the process. The throughput is the number of items that can be completed in a specific amount of time. And when we understand these two parameters, it is possible to estimate the completion of a specific task, but also it will help us to give an idea about the completion of the project itself. An important thing is about adjusting estimates for uncertainty. Now, when we look at uncertainty, we look at risks and leads, and we also want to include that uncertainty into the estimates of time and cost. When we want to reduce the effects of this uncertainty, we can increase the estimates using contingency. So we will use contingency parameters to adjust for the uncertainty. But we can also use the computerized simulations like Monte Carlo, or use the PERT on the 3-point formulas like I described before. So that was it about estimation. There are a lot of things to do about estimating. Estimating in project is very important, and it is, let's say, an art to find good ways to estimate the exact duration and cost of the activities. Of course, you need a lot of experience, but you will get that experience. There are a lot of databases, and there are a lot of models that you can use. Also models that consider the risk element, the uncertainty elements. So that's everything about estimating. In the next video, we will be talking about schedules. Keep up the good work. Thank you for watching, and I will be seeing you in our next videos. Bye bye.